Good morning, ladies and gentlemen. Welcome to this video on how to find local maximums and minimums. So, what are we looking at here? Well, we know functions have curves. We know at certain points there will be peaks and troughs or maximums and minimums. And what we can expect of these maximum and minimums is for f dash of x to be 0. So here, on that graph, f dash x or f dash a when x equals a will be equal to 0. However, just finding f dash a equals 0 only tells us one of three things is happening. Either we might have found a local maximum, local minimum, or a stationary inflection point, i.e. where the graph goes horizontally for an instant and then continues on its journey. So, when you're finding a local max or min, it is not sufficient just to find f of a equals to 0. You must accompany your proof with a Sine diagram. So if you're asked to find a local maximum, you find it and put a Sine diagram in. Sine diagram looks like this. So for example, for a local maximum, what it would look like is the slope is positive, 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 0. And that's indicated here. Then it goes negative, negative, negative there. And the way you do this is you find f dash of a equals 0. So you find a where it equals 0, and then you sub in a number from here, from there, and from this side to give you the signs. And you need to show you're doing that in order to obtain the marks. All right, so I'll go through an example. We are just going to look at really local max and min today. Stationary inflections will come later, but do be aware that you can get f dash a equals to 0 from a stationary inflection like that, and your Sine diagram will look like one of these. All right, take this glorious graph. Love the pixels. All right, the question is, find the maximum minimum points for the function f of x for x is between and equal to -3 to 5. So we are looking at the domain -3 to 5. And that domain is important. We'll come back to it. All right, first steps. And a little plan for finding maximum min. Differentiate the function. All right, it's a polynomial, so that's pretty easy. F of x equals 3x squared minus 12. Solve for f dash of x equals to 0. Therefore, 0 equals 3x squared minus 12. Let's add 12 to both sides. Let's divide by 3 and square root both sides. So x equals plus or minus 2. All right, now let's substitute those points in to our graph, substitute those x values into our function to find the actual maximum minimum points. So if x is plus 2, f of 2 equals, well, 3 times 2 squared is, what, 3 fours are 12, take 12 is 0. And f of minus 2, or don't make that mistake, everybody. If you sub it into the derivative, it'll come out as 0. By definition, you solved it to do that. Don't sub it into the derivative. You want to aim for the actual function. Yeah, made the mistake just to show you guys what not to do. All right, f of x to the power of 3 is 8 minus 12 lots of 2 plus 3. 8 take 24 is what? Minus 16 plus 3 is minus 13. By all means, use a calculator to do it. So what we're suggesting here is that there is a turning point at 2 minus 13. 2. What could be minus 13? All right, so great. If we're looking at the graph, we're expecting, okay, there's a turning point. Now, note, from here, you don't necessarily know with what type of turning point it is, whether it's maximum or minimum. But we know there's one at 2 minus 13. All right, what about f dash minus 2? No, f of minus 2. All right, so if we're looking at f of minus 2, that's minus 8 plus 24 plus 3 is 19. And you can see it minus 2, 19, yeah, it works out. And note that they're not always going to be as simple as a polynomial. I'm just showing it as an example of the process you need to go through. So we know there is another turning point at 2, 19. Now, this isn't enough. I found 2 turning points, but I haven't shown what type of turning points they are. So for this one, the Sine diagram is going to be, you draw an arrow, this is x, and this is the Sine diagram for f of x, and here at 2. And what we're going to do is substitute a number in either side of 2. So pick the number 3, and we go into the f of x. So if we sub in 3 to here, it's going to come out to be a positive number. And if we sub in the number 1, it'll come out to be negative. If the slope is negative in this portion, so imagine negative in this portion and then positive in this portion, therefore this is a minimum. In fact, we could even say it's a local minimum. Local minimum because there might be other points that are bigger or small, rather smaller than it in the future. And we'll look at why that's dangerous. All right. Finally, the Sine diagram for this, for f dash x, when x is minus 2, we put in a value below minus 2, put in minus 3, it'll come out positive. Above it, it'll come out negative. That's positive, negative, so therefore it's going to be a turning point maximum. So this is local max. Sorry, my screenwriting is not amazing today. Or ever, actually. So what we're looking at is 2 points, local minimum, local maximum. And with a Sine diagram, we've actually done enough to show it. There is one tiny trap that's not always applicable, but it is in our particular example. We're asked to find the maximum minimum points for this function between the domains of minus 3 and 5. Now, minus 3, if you look at the graph, is going to be here. It's not a maximum minimum because we've already found this maximum and this minimum. However, if you look at the other extreme, 5's way up here. So technically, the maximum of the function between minus 3 and 5 is the end of the domain up there. And this is quite easy to spot if you're able to graph it. But if you go into a non-calculator section in the exam and are asked to do this problem, then it's much more difficult. So in a non-calculator section, I would check the domain extremes, so check either end to make sure they aren't the actual maximum and minimum. Because the correct answer for this question here is find maximum minimum points of the function. The minimum is this one here, and the maximum is not that, it's this one, which is just kept by subbing 5 into the original function. So it's worth being aware that your maximum minimum might be at the extremes of the domain rather than the local turning points. All right, anyway, here's your, I guess, plan. You need to differentiate the function, solve for f of x, sub the solution to f of x to find the coordinate points. Sometimes check the extremes to make sure the extremes aren't the actual ones. Then you need to use Sine diagrams to prove that they are actually turning points, not just stationary points of inflection that you've found. Of course, you can use your calculator to check this. So you should be graphing on the calculator using find max, find min, just to double check that you've got the right thing. All right, thank you very much for watching. We'll see you next week.